The given math is the value of e to the power 1 by z dz, where c is the counterclockwise unit circle on z plane, is equal to option A is 0, option B is 2 pi, option C is 2 pi root over minus 1, and option D is infinity. This math is given by one of my viewers named Shumit Mondal. So now I solve the math. So the math is f of z equal to e to the power 1 by z. We know the e to the power x series is 1 plus x by 1 factorial x square by 2 factorial x cube by 3 factorial plus dot 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 dot. If we consider 1 by z equal to x, then we write f of z equal to 1 plus 1 by z by 1 factorial 1 by z square by 2 factorial 1 by z cube by 3 factorial plus dot 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 dot. Clear? Then we can write 1 plus 1 by z minus 0 plus 1 by 2 factorial z minus 0 whole square plus 1 by 3 factorial z minus 0 whole cube plus dot 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 dot. It means for the value of z equal to 0, the function tends to infinity. That means the function holds singularity. So z equal to pole, or z equal to singular point, or we can say z equal to singular point, same thing. Clear? Or z equal to singular point. Clear? Now the next step, we have to find the residue. This is special type math or different type math. In this case the residue is, we write the residue, or we denote the residue by r1 equal to 1. Why r1 equal to 1? Because we consider coefficient of 1 by z, because we consider coefficient of y by z in the above expansion. Clear? When we see the series is infinite series, in this case from the above series we consider r1 means residue 1 for the pole z equal to 0 is 1. Why 1? Because coefficient of 1 by z is the residue in this case of the above expansion. Clear? And here the circle is unitary circle, so mod z equal to 1. It is given in the math. So z lies between -1 to +1. Clear? -1 to +1. So by using the theorem of residue theorem, so by residue theorem, the value of 1 lies on the circle, so we use residue theorem. And by residue theorem, in the formula of residue theorem, C f of z dz equal to 2 pi I r1 plus r2 plus dot 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 dot. Clear? So here the math is c e to the power 1 by z dz equal to 2 pi I. Here residue is just one residue r1. Clear? So the answer 2 pi I, and the value of residue is 1. So the answer 2 pi I, or means the answer 2 pi I means 2 pi root over of minus 1. That means the option C is right option. Clear? The option C is the right option. Clear? If you asked me why we choose residue 1 as the why we choose residue 1, or why we choose the coefficient of 1 by z as a residue, because of that up to the mark, I think the math is clear. Because why we choose, because we consider z equal to 0 as a simple pole, and the formula of r1 equal to limit z tends to 0, so z minus 0 into the function 1 by z. The formula z tends to alpha, z minus alpha, f of z, from the formula of simple pole. Clear? So limit z tends to 0 e to the power, we can write this as e to the power 1 by z by 1 by z. Clear? And limit z tends to 0, and this function mean 1. If we expand the series, 1 by 1 plus z by 2 factorial z square plus 3 factorial z cube plus dot 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 by 1 by z. These are so so small terms, so we neglect these terms, and the series become, if we neglect these terms, because this is so small terms, the series becomes limit z tends to r1, limit z tends to 0, 1 plus 1 by z by 1 by z. Clear? 1 by z. So after divided, limit z tends to 0, that means z plus 1 by z by 1 by z, z cancel, that means limit z tends to 0, z plus 1. So after putting the value, r1 is 1. So r1 is 1, so we consider r1, is 1, and coefficient of 1 by z is the above expansion. Clear? Okay, thank you.